Welcome. In this video we will be looking at and discussing how to secure AWS resources. So the main way we go about securing or working with resources is through the AWS Identity and Access Management service. And we use this service to control which people and processes get past the wall guarding our resources, authentication, and what they're allowed to do once they're in authorization. Protecting the root user. So when you first join AWS and you log in, that's known as the root user. For practical reasons, the root user has the permissions necessary to perform any task on your account. That includes launching any resource in any region and authorizing any expense. The problem is that actively using the root user over the long term with only minimal protections presents a significant security risk. Should the root credentials ever be compromised through an attack, there will be no limit to the potential for mischief. All of your data could be stolen or deleted, or the attacker could run up hundreds of thousands of dollars of charges running a rogue crypto mine, for example. The recommended best practice is therefore to protect this root user account by creating a complex password and implementing multi-factor authentication, and for most administration activities, use an IAM user instead of the root account. So you'd be logged in with the user that has a little limited, access. Maybe just it might have admin access to certain services, but not everything, right? So that's the best practice. But at least you need to lock down the root user with a complex password, and then also enable multi-factor authentication. So authentication, whenever you log into work with your AWS account via the AWS Management Console, running a command from the terminal of your personal laptop, or connecting a remote application to AWS resources at the programming code level, you'll need to prove you are who you claim to be, and that who you claim to be has the right to access what you're after. Often that will mean providing some kind of user ID and password. In the case of programmatic or command line access, you'll need a set of access keys. Opening a remote login session to a Linux instance on an EC2 will require a valid key pair. Right? So you have to authenticate and prove that you are who you say you are, and then be authorized and have authorization to access what you need access to. Oop. Alright, passwords. While you're still learning your way around AWS, you'll probably do most of your work from the browser's AWS Management Console. As you'll learn in Chapter 6, working with your AWS resources, using the command line, specifically the AWS command line interface, can be a far more efficient way to get things done, but the AWS Management Console works as well. The root user logs in to the AWS Management Console with the associated email address along with the password set when the user account was created or subsequently updated, and hopefully it's complex. But as you no doubt already well aware, not all passwords are created equal. If you want your account to have any chance of surviving an attack, you should avoid passwords that can be easily guessed. Instead, choose complex and long passwords that include upper and lower case characters, numbers, and symbols, Even better, use only random generated strings that aren't even distinctly based on the stuff going on in your life, like your birthday. And never ever reuse passwords across multiple accounts. Don't think you can remember passwords like those? Welcome to the club. The simple and most effective solution is to use password managers like LastPass or Dashlane or KeePass2. As mentioned, the first step in protecting your root user is to give it a high quality password, but that doesn't mean you should let other users off the hook. You'll soon see how to create such users, but before that happens, you should have an appropriate password policy already in place. You can configure a policy from the account settings section of the IAM dashboard that will require passwords used by all users on the account and to conform with minimum complexities. So let's go to our account and let's go to IAM. So management, let's see here, security and identity compliance, IAM. All right, and then account settings, right? I don't want to do that. Password policy, right? So here's the password policy under account settings. Use the following custom password policy. Minimum passwords, 8 characters, require at least 1 upper, 1 lower, at least 1 number, at least 1 non-numeric, and allow users to change their own password. But you can change this, right? You can designate it, you can make it 16 characters, but whatever you do, then it's required, right? Enable password expiration, prevent password reuse. So you can make this password policy and apply it, and it applies to all users. And once again, I went to IAM and then account settings, and then it's this password policy. But then we also want to enable multi-factor authentication. This adds a second layer of security to our logins. Once it's enabled, a user will need to provide not only a password to authenticate, something they know, but also a second factor, a temporary digit token sent through a preset device, something you have, like a smartphone running an authenticator app. Multi-factor authentication works by associating a physical device, either a universal two-factor or multi-factor authentication compliant device like a YubiKey, or a smartphone that has an authenticator app installed attached to your account. When you try to log in, you'll first enter a password, and then a short-lived code, usually a 6-digit number, will be sent to your multi-factor authentication device, and you'll only need to read the number and enter it into the appropriate field on the login page, and you'll be allowed in. While complex passwords and multi-factor authentication are important for any account user, they're both especially critical for the root user. So it is definitely a good idea to enable multi-factor, especially on the root user. And so let me go, it's already enabled, but let's go here. Well, let's see, do I have any users? I do have an admin user. All right, so I've got an admin user and the keys are pretty old, so but it's got MFA, so I go here to the user here, and then security credentials, So MFA, this is where you would sign it up, and you would be able to enable it here, and so it's just kind of hard to show it. So let's create a new user, MFA test. We'll give it console access only. We'll have it auto-generate a password. User must create a new password or next sign-in. Next, we'll give it access to S3. Next, and we'll create the user. Okay, so it's got the email. You can email the instructions on how they log in. Alright, so we'll close that. So now we have this new user, and MFA is not enabled. So now we'll go to the security credentials, and so assign MFA device. So what we need to do is we click manage. Now if we have a smartphone, you use the virtual MFA. If you have a YubiKey or other MFA device, right? So you can use these, but usually you just download the Authenticator app onto your smartphone, and then you hit continue, and then you would show the QR code and just take a snapshot of the QR code from within the Authenticator app, and it will generate some codes. You enter in the code, the first code, wait for it a second, and then enter in the second code, and then you assign the MFA device. So you show the QR code, take a screenshot of the code from within the Authenticator app. Then it generates codes. You put in the first code, and then wait 30 seconds, it's a minute, and generate the second code, enter it in, and that'll assign the MFA device to it. And then there's no keys generated for this user because I didn't give it programming permissions, but I could create keys for it for programming access if I wanted to. But that's the multi-factor authentication. Let's see here. Alright, so and then users, right? So we're limited to 5,000 IAM users per account. If you want to create a primary admin to replace your root user for day-to-day operations, you would just select the administrator access policy. On the last user, we just selected the S3, but I could have selected administrator and gave them pretty much full admin, which will provide enough permissions to get most admin tasks done without exposing your account to unnecessary risk. And to get around the 5,000 limit, you can use Federated Access and use existing users in your your Active Directory, and we'll discuss Federated Access in a bit. But you could also create a management application that uses Cognito for authentication. Cognito is a AWS built-in security authentication app that can also leverage social media accounts. So users could log in using their Facebook or YouTube or Gmail accounts, and that or you can create users incognito as well that aren't IAM users. Then groups, right? As the organization devotes more team members to your AWS organization, manually assigning permissions to individual users one at a time will become a tedious and time-consuming chore. Using groups to administer these permissions associated with multiple users in batches can get all that done much more efficiently. but you are limited to 300 groups per account. You can request a raise and request up to 500 groups, but it is limited. But you also should take a look at using roles. Groups are good, but roles can be more effective and maybe more appropriate. Like users and groups, IAM roles define the limits for what you can be done with your account. The important difference is that unlike users and groups, roles are for the most part used by applications and services rather than people. When creating a role, you begin by defining a trusted entity, the entity or beneficiary that will be trusted to use the role. The entity could be an AWS service, such as EC2. It could be an identity provider by a third-party federated identity provider like Google or Amazon Cognito, which will allow a digital identity to be linked across multiple identity management systems. Or it could be even a different AWS account. You might, for instance, need to give users logged into your mobile application through their Google accounts access to specific resources on AWS, such as data storing on S3. You'll have to specify exactly what permissions you want to give the role, or in other words, what you want the users and beneficiary processes to be able to do. You'll then choose the policy that best fits your anticipated needs and associate it with the role. And from that point, any authenticated mobile app user will have access to those S3 resources. You are limited to 1,000 roles per account, and you can request an increase up to 5,000 roles per account. But that should be more than adequate for most use cases, and in a lot of cases that you probably have an account per app, maybe even. So 1,000 roles, 5,000 roles per application is going to be more than what you normally would need to manage an application. Federated access. And now that we've brought it up, this whole business of federated identities, we should discuss on how you can incorporate them into your authentication profile. Federation expands the available tools for managing authentication beyond the simple IAM options you've already seen. You can integrate third-party standards like Security Assertion Markup Language, or SAML, or Microsoft Active Directory into your infrastructure. This lets your users use existing login sessions to add single sign-on across your AWS infrastructure, enables seamless access between your mobile apps and back-end resources. For example, DynamoDB databases or S3 based objects. Besides the IAM role configuration, you've seen a bit earlier, federated access to AWS resources can be handled through the AWS single sign-on service. For Active Directory integration with cloud-based Microsoft SharePoint and SQL Server-based workloads, you would use the AWS Directory Services for Microsoft Active Directory, more commonly known as AWS Microsoft AD. But the whole point is if you use something such as Microsoft Active Directory or some other database, you can use SAML or Microsoft Active Directory services and utilize the already existing company users and accounts, and through this federated access, these existing accounts can be used, and you can secure your applications and resources based on the existing users. And so, like I said, that you can create single sign-on experiences where the users sign in once and they're able to go from the mobile app to storing files on S3 or reading data out of the database, that's in DynamoDB, but they only logged in with their existing users and passwords from their Active Directory account. So it makes it much simpler, and it also expands the use, so you're not using any of the IAM users and groups. And you might be using some roles in this example because you have applications that have role access, and the role is granted to these Active Directory users. But you've got 1,000 roles, or up to 5,000 roles if you ask for an increase for that application, so that you can create some pretty granular applications and access. Alright, so we're going to end here on this video, and then we'll go into some reporting and some compliance features that we can do with securing our resources, and even some encryption, but we'll cover that in our next video.